Lesson 12. Forces, Torque. Section 12.1. Magnetic force on particle. AX, AY, and AZ are the unit vectors in the directions of the x-axis, y-axis, and z-axis in Cartesian coordinates, respectively. A uniform magnetic field of BAX teslas exists in a region. A particle, charged with positive q coulombs, is moving in the y direction with a velocity of uay meters per second. Then, a force of negative Faz newtons is generated. The relationship between the force F, charge q, velocity u, and magnetic flux density B is expressed by this equation. The direction of F follows the right-hand screw rule as shown in the figure. The angle theta is measured from U to B. If the particle is in a vacuum, the magnitude of its velocity remains constant. Moreover, F is always directed to the center of the circle. R denotes the radius of the circle. The magnitude of the force F equals QUB. The centripetal force exerted on the particle is given by this equation, where m is the mass of the particle. Thus, the radius is derived as shown in this equation. Exercise 12.1.1. Pause the video and answer the problem. Find the force F on an ionized carbon atom. The answer to exercise 12.1.1. Pause the video, and check the answer. Exercise 12.1.2. This is your homework. Pause the video, and answer the problem. Section 12.2. Electric and magnetic forces. Suppose that a uniform electric field EAX volts per meter is also present along with the magnetic field B. Another force Fe is exerted on the particle. The magnetic force from the previous section is now denoted as Fm. The combined force F is given by this equation. This is called the Lorentz force. The trajectory of the particle is helical. Fe and Fm are perpendicular to each other. Thus, the motion in the x component and that in the yz component can be analyzed independently. The motion in the yz component is a circular motion, the same as that in the previous section. The x component of the force is constant, and it produces a constant acceleration a in the x direction. The motion in the x direction is obtained as shown in this equation. The author of this material is Takeshi FURUHASHI, Professor Emeritus, Nagoya University. If you have any questions, send emails to this address.